Hello students, how are you? Hope you are having a good day. Since yesterday, I have been facing a problem. I hope you can try to help me solve it. I have two good friends, Mohan and Vijay. Now, since yesterday, Mohan and Vijay are fighting because each of them claims that he got more marks in a maths exam. Mohan got 36 marks while Vijay got 32 marks. Now, Mohan got 36 marks in the test and Vijay got 32 marks in the test. Just by looking at it, can we say who got more marks? The answer to the question, who got more marks here? Clearly, if I have to just look at the marks, yes, Mohan did get more marks. Now, if it is so obvious, why do we think both of them are fighting over I got more marks, I got more marks? That could lie in, these were 36 marks that Mohan scored out of how many marks? What was the total mark of the exam? Mohan got 36 marks out of a 50 mark question paper. Okay. Now Vijay on the other hand got 32 marks out of a 40 mark question paper. Now do we see why there is a problem? The marks that they are scoring is not in the same question paper. They are getting, Mohan might look like he is getting more marks, but his paper is actually different, right? Now they are fighting over which is more, whether 32 out of 40 is more or 36 out of 50. How do we compare this? Obviously, we cannot compare dissimilar things. We cannot compare the marks in one exam to marks in another exam. We have to bring something common to both of them, correct? What will that be? I have to make this 40 50 or I have to make this 50 40. Okay. So 36 out of 50, these are the marks one of them got. 32 out of 40, these are the marks the second person got. Now to compare their marks, I need to make the denominators same, correct? Now how can I make the 40 50? We can just multiply it by 5 by 4, right? Multiplying this by 5 by 4, similarly multiplying the numerator by 5 by 4, right? How much is that? 40, 4 10s are 10 5s are, this denominator becomes 50, 4 8s are 32, 8 5s are 40. Now, when we equate both their marks to a common denominator 50, we realize that Mohan got 36 out of 50, but Vijay's performance is equivalent to 40 marks out of 50. This is one way of comparing their marks. The other way could be, while we took Vijay's 40 mark question paper to a 50 mark question paper, we could have also brought down Mohan's 50 mark question paper to a 40 mark question paper, right? So Mohan got 36 out of 50 and Vijay got 32 out of the 40. So how would Mohan have performed in a 40 mark question paper? We can multiply 50 into 4 by 5. Similarly, this into 4 by 5, right? So this is 5 10s are 10 4s are 40, 36 4s are 144, 144 by 5, that would be 28.8. So what does it mean? Here also we can again see Vijay only scored more, right? Had Mohan scored 36 out of 50, Vijay would have scored 40 out of 50 on a similar paper. Similarly, on Vijay's paper, where Vijay scored 32 out of 40, Mohan would have scored only 28.8 out of 40. Now, again, the question is, why are we changing the 40 to 50 or the 50 to 40? Instead of 2 people, let's say we have 3 people. Let's say we have Akhil also joining them. And Akhil says, I got 60 out of 80. Let's compare my marks also. It's always a bit of a trouble agreeing on should we scale all of them to 40 or to 50 or to 70 or to 80, correct? What if we had a common number to which we can scale up or scale down everyone's marks? That's the reason we have the term percent. Percent, per means for, cent means 100. For 100 or out of 100. Instead of fighting with 32 out of 40 or 36 out of 50, why can't we just say out of 50 you got 36, out of 100 how much would you get? 100 is easy to get. 50 into 2 becomes 100. So his marks would also have doubled. That would be 72 out of 100. So we call this 72 for 100 or 72%. Similarly, Vijay's marks 32 for 40. How can we raise this 40 to 100? Multiply it into 2.5, right? So into 5 by 2 into 5 by 2. 40 into 5, 200 by 2, that's 100. 32 by 2, that is 16 into 5 is 80 by 100 or 80%. Now, as we all very well know, this is how marks are calculated for the aggregate. This is how any board gives the final marks, the total marks, expressed as a percentage. Why? Because it is easy to compare. Someone could be from a state board, someone could be from a CBSE board, someone could be from an ICSE board, where the total number of marks could be different, right? Someone saying I got 800 out of 1000, someone saying I got 670 out of 800 is different and definitely difficult to compare. Instead, expressing everything to a common base makes things easier to compare. Here Mohan can actually say he got 72% of the marks, Vijay can say he got 80% of the marks, and therefore Vijay definitely got more percentage. While the number of marks that Mohan got is more, the percentage of marks that Vijay got is definitely higher, and therefore now we can actually call both of them and tell them Vijay secured a higher percentage of the marks, right? The problem is solved. So in this video, we will try to learn about percentages and their applications. Today, we are going to learn about percentages and their applications. Just like we've seen in a question a minute ago, remember Mohan and Vijay. Towards the end, we could calculate and say that Mohan got 72 out of 100 marks, while Vijay got 80 out of 100 marks. Now, what was it? 72 for 100, 80 for 100, or 72 per 100, 100 is cent. So, he got 72% of the marks, while Vijay got 80% of the marks. Percent, nothing but per 100 or out of 100. Percentages are also fractions. The only thing is the denominator is 100. So, we can say any fraction with a denominator of 100 is a percentage and vice versa. For example, 7 out of 100. What is it? It is 7%. Or 20%. How much is that? 20 out of 100. 13%. 13 out of 100. Now, instead, what if we have a fraction? Let's say 1 by 4. Let's say we have 2 by 3. 1 by 4 is also a fraction. Just like I said, every fraction can also be expressed as a percentage and vice versa. 1 by 4 is a fraction. How do we change it to percentage? This can be read as 1 by 4 or 1 out of 4 or 1 per 4. But percentage is about percent, but here I have only per 4. So I have to change the denominator to 100, then automatically I'll get the percentage value, right? So what can we do? How can a 4 become 100? By multiplying into 25, right? So let's multiply both the numerator and denominator by 25. 1 into 25, that would be 25 out of 100. So the 1 by 4 can be represented as 25%, 25%. When we think about converting 2 by 3 also into a percentage, like in the previous case, converting the 4 to 100 just by multiplying 25 was easier. But here, converting the 3 into 100, we have to multiply by something which is not an integer. So it's not a very convenient method, right? So do we have a slightly better method, a different approach? Let's go back to the 1 by 4 once again. 1 by 4, previously what we did was, we converted the denominator to 100 and therefore we represented the 1 by 4 as 25 by 100 and we called it 25%, right? Now the same thing, instead, let's multiply 1 by 4 into 1. Why are we multiplying with 1? 1 is the same as 100%, right? 100%, which is 100 out of 100. 100 by 100 is 1, correct? So 1 by 4 into 100%, if we take the percentage term aside, 100 by 4 is what this is. this is 25. So this is 25%. So what we do know is just multiplying any fraction into 100 percentage will also directly give us the same result. For example, now let's look at 2 by 3. 2 by 3, instead of converting the denominator to 100, let's just multiply it into 1, which is 100%. 100%. Now what? 2 into 100 is 200 by 3. This is 200 by 3%. Now this we can express as a mixed fraction. 200 by 3, 3 6 are 18, 26 are 66, 366 are 198, 66, 2 by 3%. So one way to convert any fraction to a percent or a percentage is converting the denominator to 100, either increasing it to 100 or decreasing it to 100 by multiplying or dividing by the appropriate number. The other way is just directly multiplying the given fraction into 100%. The percent will stay aside, just multiplying by 100 and simplifying it. Now, there's a notation to represent all of this. Each time we don't have to write the entire term percent or percentage. Percent or percentage can be directly represented by this sign. So, what is this? 70%. 70 by 100. What is this? 18%. 18 by 100. What is this? 72.5%, means 72.5 out of 100. Now, let's practice converting fractions to percentages and vice versa. For example, we have 1 by 2, 1 by 5, 1 by 6, 1 by 8, 1 by 9. Let's see. What is this? 1 by 2. We would like to convert it into percentage. We can do it in two ways. One, converting the denominator to 100 by multiplying into 50 into 50, or alternately just multiplying it into 100%. So 1 by 2 into 100%. Now as we've learnt, percent is by 100, 100 by 100, which is 1. So there's no problem. 2 50s, 1 by 2 is 50%. Similarly, 1 by 5 is 1 by 5 into 100%. What is that? 5 20s are 20%. Similarly, 1 by 6 into 100%. How much is that? 100 by 6. 100 by 6%. Can we leave it like that? No. There is a 2 which is common to 106, right? Divide it. 50 by 3%. Can we leave it like that? We can further also simplify this as 3 16s are 48. So 16, 2 by 3%. Similarly, 1 by 8 into 100%. We can say there's a 50, there's a 4. Similarly, there's a 25, there's a 2. So it is 25 by 2% or 12 1 by 2%. Similarly, 1 by 9 into 100%, which is 100 by 9, which is 11 1 by 9%. So we learned that multiplying any fraction into 100% will directly give the fraction in terms of percentages. Now similarly, if you have to do the opposite of that, if we are given a percentage and we would like to convert it into a fraction, let's say 75%, 80%, 60%, similarly 45%. What about them? 75%. The symbol itself indicates that it is per 100 or out of 100. So 75 per 100. So this is the fraction representation. Should we leave it like that? No. The highest common factor of 75 and 100 is 25. So we can divide 75 by 25, 25 3s and 25 4s. So the fraction form is 3 by 4. Similarly, 80% is 80 per 100 or 80 out of 100, which is 80 by 100. We just have to divide by 100. Now 8 by 10 also, there's a 2 here and there's a 2 here, right? So 2 4s, 2 5s, it is 4 by 5. 4 by 5 is 80% or 80% is 4 by 5. Similarly, 60% is 60 divided by 100. So what is that? 6 by 10, which is 2 3s by 2 5s, 3 by 5. Similarly, 45%. 45 divided by 100 or 45 out of 100 or 45 per 100. 5 divides this 9 times, 5 divides this 20 times. So, 9 by 20. 9 by 20 is equal to 45% or 45% is equal to 9 by 20. So, here we have seen how to convert fractions to percentages, and here we have seen converting percentages back to fractions. Let's take a moment to go back to the example that we discussed at the beginning of the video. At the beginning, we discussed about two friends, Mohan and Vijay. Mohan got 36 out of 50 marks, while Vijay got 32 out of 40 marks in two different tests. Now, if we look at it, Mohan's percentage is 36 by 50 into 100%. 100 by 50 is 2, 36 are 72% of the marks that he got. Similarly, Vijay got 32 by 40 into 100, which would come to 80%. Now, let's say someone doesn't have any information about the actual marks scored. We do not have this information, or we do not know the total marks of the exam. What we do know is a person Mohan got 72 marks in a maths exam and a person Vijay got 80% marks in an exam. Now, if someone asks me who got a higher percentage of marks in a maths exam, we can say yes, Vijay got a higher percentage of marks. But if the question I ask you is who got more marks in his or her exam, can you tell me who got more marks? Is it possible? Based on the 72%, 80%, can we actually say who got more marks? We can't, right? Now, why can we not? Because this can be 72% out of 100 or this can be 72% out of 200. We don't know. Vijay's exam could have been for 100 marks and Mohan's exam could have been for 200 marks. It could have been for 300 marks. It could have been for only 50 marks or it could have been for 25 marks. So, while the percentage gives us a fair understanding of what percent of the total marks a person got, is that sufficient to understand how many marks the person got? No. Therefore, when we say 72%, it is always accompanied by 72% of something, correct? So, percentage in that way is a relative measure. Percentage is a relative measure. Why? Because we do not know the absolute value. It's a relative measure and it is always percentage of something. 72% of 100. We will know he got 72 marks. 72% of 200. We know that he got 144 marks. 72% of 1000. We know he got 720 marks. Similarly, think of this. When the government charges a 10% tax or let's say an 18% GST, the question should be 18% of what? Is it 18% on the cost incurred? Is it 18% on the MRP? Percentage is always on something. Percent of what? Percent on what? So, percentage is a relative measure. It is always calculated on something. It is not an absolute value. Please look at the question on the board. If John has 120 rupees with him and he spends 30% of it, how much will he be left with? So, John starts with 120 rupees in his pocket or in his bank or whatever. He had 120 rupees, out of which he is spending 30%. Now, what is 30%? 30%, when I write the 30% here, separated from everything else, does it have a value of its own? 30% of 10 has a different meaning and value. 30% of 100 has a different value. 30% of 150 has a different value. Here we are talking about 30% of it being the 120 rupees, correct? So, 30% of 120 rupees is what John is spending. Of we know is multiplication, right? So, 30%, 30 out of 100, 30 by 100 into 120. 30% of 120 is 30 by 100 into 120. So, if we calculate this, the 0 cancels, the 0 cancels, we will have 3 into 12, 36 rupees. So, out of 120 rupees, he spent 30%, which is 36 rupees. So, from 120 rupees, when we remove 36 rupees, we are left with 84 rupees. So, to answer the question, the straight answer is 84 rupees. Now, could this have been done in a different way? Right? I have a certain amount and I spent 30% of it. Now the value I have initially is 100% of what I have, right? This is everything that I have. From that I am removing a certain value. From that I am subtracting 30%, right? So how much will I be left with? That will be 70%. I am left with 70% of my initial value. Now what is 70% of the initial value? 120 rupees. 70 by 100 into 120, which is the 0 gone, 7 12s are 84 rupees. As we can see, this is no different from the answer that we previously got. Now, every time instead of calculating the value spent, subtracting it and then getting the final value, we could also say, I started with 100%. If 30% is spent, I am left with 70%. I can directly calculate, right? So that way also we could get the answer much faster. In that way it would only be one calculation. 70% of 120, which is 70 by 100, which is 7 by 10 into 120, we can calculate the 84. Look at one more practice question on the board. Three friends A, B and C went to a bakery. The total bill was 200 rupees. If A paid half the bill, half the total, and B paid half of the remaining amount, C paid what percentage of the total bill? Here there is scope for making a mistake. Please pay attention to this part particularly. Half of the remaining amount. The total bill was 200. Okay. Three of them went to a bakery and the total bill was 200 and A paid half the bill. Half the bill is nothing but 50%. Whichever way we do it, he's paying half of the total amount, half of 200. That would be minus 100 rupees. So this is what A is paying. A has paid 100 rupees. Then B is not paying the remaining half. B is paying half of the remaining amount. So of the total amount 200, when A pays 100 rupees, how much is still remaining? 100 rupees is still to be paid. Now what is B doing? B is paying half of the remaining amount. So he is paying half of 100, which is 50 rupees. So A is paying this amount and B is paying this amount. So 100 minus 50 is 50. So who will pay this amount? Obviously C should pay the remaining amount. And the last question is, C paid what percentage of the total bill? He paid 50 out of 200, that is the fraction. Now we need to express this as a percentage, right? We can either multiply into 100% or simply we can see that this is 200, this is 50. We can half both of them. 200 when halved becomes 100. Similarly, 50 when halved becomes 25. So 25 by 100, or C paid 25% of the bill. That's the final answer. Here we can go back and check that A actually paid 50%, B paid 25% and C paid 25%. But the question is only really asking about C, who paid 25% of the bill.